Donc, je ne parle plus parce que maintenant c'est le tour de Dr. Reiner. So I will not present you Dr. Reiner because we are ahead of time. We are in a hurry. But for sure, he's a good expert. He would be talking about 2 sessions in 1 hour. He will do his best, but I am sure you will like so much. So, Reiner, thank you very much. Now it will.
Good morning, everybody. Thanks for the kind introduction and thanks for the invitation to this workshop to contribute. And I hope that this presentation will be helpful and useful for your country. So the presentation will comprise 3 parts. First, monitoring of POPs in human biomonitoring. Then, as reliability of results is important for any discussion and conclusions, few words on analysis, in particular long-term quality control, and then finally monitoring of POPs in foodstuffs. So as you know, humans are exposed to many chemicals in various ways. As example, the main exposure ways to chlorinated paraffins, different uses, plasticizers, paints, adhesives, and so on. So chlorinated paraffins can also be used in consumer products where they can then finally contaminate humans by dermal absorption. Chlorinated paraffins can then evaporate and can be inhalated, so air or dust can contribute to human exposure. Chlorinated paraffins can evaporate and bioaccumulate in feed or food, or also can be used in kitchen appliances, and it has been found that contaminated kitchen appliances contributed to contaminated food, which then caused concern. Human exposure to harmful chemicals can cause various health problems, ranging from immediate or acute symptoms to long-term or chronic effects. Here, as an example, the risk assessment for polybrominated diphenyl ethers, PBDEs, in food, an EFSA assessment, EFSA European Food Safety Agency of 2023. And you see that these address acute toxicity, reproductive toxicity, immunotoxicity, neurotoxicity, genotoxicity, carcinogenicity. So a document of 230 pages without appendices, and this shows just the overall complex toxicological assessment. That's only one POP as example. As Key already pointed out, the main objective of the Stockholm Convention is the protection of human health and the environment from negative impact of listed man-made POPs by reducing or eliminating releases to the environment. And Key already has explained the expansion of number of chemicals, the effectiveness evaluation periodically required, and the GMP. Human biomonitoring can be defined as method for assessing human exposure to chemicals or their effects by measuring these chemicals, their metabolites or reaction products in human specimens. Human specimens can be bodily fluids as breast milk, blood, urine, saliva, sweat, others as feces, hair, teeth, or nails. Compounds measured in these specimens can be persistent organic pollutants, non-persistent organic pollutants, their metabolites, metals, or others. The EU has started a biomonitoring process with 28 countries participating between 2016 and 2022. 17 substance groups were identified as priority substances. These are partly chemical groups like aniline, bisphenols, PAHs, PFAS, phthalates, sometimes product groups like emerging flame retardants, pesticides, mycotoxins, and also chemical mixtures were addressed. A review of 2023 shows the increasing number of studies on groups of contaminants in human milk. So in 1960 to 1980, just organochlorinated pesticides and halogenated flame retardants, two groups were of interest. And over time, the number of groups increased to 20. So there is an overwhelming amount of data available. And in the following, I try to get some conclusions what might be of importance in general and for your country. So first, not all compounds measured in human biomonitoring studies are POPs. So in the following, I will address POPs as listed by the Stockholm Convention. Then second, as Key already has mentioned, not all matrices are key matrices but recommended by the guidance document on the GMP. Key has already clarified that there are three key matrices: air, water porphyphers, and human milk and blood. And in the following, I will focus on bioaccumulation in humans with human milk as key matrix, and the WHO UNEP coordinated exposure studies as key contributor to the GMP. WHO has started exposure studies in human milk at the end of 1980s, early 1990s, focusing initially on PCBs, dioxins, and furanes. Also, the third round was started in 2000 with this focus. In 2001, the Stockholm Convention was signed, and WHO asked us as a pilot study to expand the number of analytes to cover also the Stockholm Convention POPs. So these studies became of interest also for UNEP. Two studies were performed jointly. Before then, UNEP took over and performed the last two studies. In the period 2000 to 2019, 82 countries participated with an increasing number of analytes of interest. And the idea was of this joint collaboration to support the assessment of the effectiveness of the Stockholm Convention. So as you understand, there is a huge amount of data from 82 countries, 30 listed POPs, 20 years. So there are three pillars for assessment. First, individually for the POPs. These 30 listed POPs as listed until 2019, two proposed POPs. Then you can address regional aspects on a country level, on UN regional base or global, and also assess time trends. As it is impossible to present all these results in one short presentation or in one short publication, a special book has been published with 13 papers or publications in 5 parts. And this book has roughly 700 pages, 300 figures, 27 authors. It was supported by UNEP and CVUR Freiburg and is open access available, so you can download the whole information, the book or individual chapters, free of charge. We concluded that there are 4 key messages. The first key message is these studies are an efficient and effective tool with global coverage as a key contributor to the GMP. So the concept of these coordinated exposure studies is to collect representative samples representative for a country. So the national coordinator should collect usually 50 individual samples from mothers fulfilling protocol criteria. From these samples, aliquots are taken to prepare a pooled, physically averaged sample considered to be representative for a country or a subgroup in the country. The analysis is performed of these representative samples in reference laboratories, which reduces, contributes to reliability and reduces uncertainty. And this was CDO Freiburg for chlorinated and brominated POPs and Örebro University for PFAS. This concept includes also capacity building, so remaining aliquots can be analyzed by a laboratory selected by the national coordinator, and then you can compare results, and so this would confirm the analysis in the country. This is an extremely cost-effective concept because the analysis of one or few pooled representative samples from human milk in a country is far less expensive than the analysis of a high number of individual samples, in particular for dioxins or chlorinated paraffins. As already mentioned, 82 countries participated from all 5 UN regions. As you might know, UN region is not equivalent to continent. So this is true for Africa. However, European countries are split between Eastern European group and Western European and others group, and others then include US, Canada, Australia, New Zealand. So it's a kind of split as we had politically between the 1950s and 1980s. And so therefore then GRULAC, Group of Latin America and Caribbean countries, and Asia Pacific are the other 2 UN regional groups. The graph on the right illustrates the participating of countries. Some countries participated only once, like US or Russia. Other countries twice, 3 times, like Australia, or 4 times, as few countries in Europe. This has already been introduced when the Stockholm Convention was signed in 2001. The so-called Dirty Dozen was listed, comprising 9 organochlorine pesticides, PCBs as industrial use chemicals, and 2 unintentionally produced chemicals, dioxins and furanes. For these 12 chemicals, the GMP guidance document recommends analyzed to be monitored in human milk, and you see 57 analytes have to be determined to cover these 12 chemicals. When the last round of WHO UNEP coordinated exposure study started in 2016, 26 chemicals were listed. At the end, 2019, then 30. So the number of chemicals analyzed for the last study, 2016 to 2019, comprised all 30 chemicals as listed until 2019, and 2 chemicals in addition on voluntary base, MCCPs and PF-hexasulfonate. For these purposes, 101 analytes had to be determined for chlorinated and brominated compounds, and furthermore PFOS, P4, PF-hexasulfonate. As you know, there is no multi-method for simultaneous determination. About half a different analytical methods are necessary to determine all analytes of interest. And it's a unique characteristic among the core matrices of the GMP that the results of the full set of 32 POPs of interest are available for samples of the 2016-19 period, including DECA-BDE, SCCP, Dicofol, P4, MCCPs, and PF-hexasulfonate. Key has already mentioned that with COP10 and COP11, 4 more chemicals were listed. At that time, 4 more chemicals were proposed for listing, and just recently 3 of these chemicals were listed, now having 37 chemicals listed and 1 still being proposed. A question is, are all these 30 chemicals equally important also for your country? So we tried to derive a relative importance from the data bioaccumulating in humans. You can try to derive a ranking based on increasing or decreasing concentrations, which is possible for chlorinated brominated POPs, which are reported nanogram per gram lipid base. Separate, of course, dioxins, which are reported in picogram per gram lipid base, and PFAS, which are reported in fresh weight base or volume base. So the example of dioxins, factor 1,000 lower concentrations than the other one, show that risk assessments need to consider potential adverse effects as well. Having this said, if you look at the range of concentrations of lipophilic chlorinated and brominated POPs in human milk from all 43 countries, participating only in the 2016-2019 period, with median, with error bars indicating minimum, maximum, then you see that the by far highest concentrations were found for DDT and chlorinated paraffins. The maximum found for DDT, 7,100, was roughly a factor of 10 higher than chlorinated paraffins, 700, as sum of S and MCCPs. However, the median concentrations are quite comparable. And then you see that MCCPs have a tendency of being higher than SCCPs. PCBs, which otherwise have been of interest for a long while, are a factor of 10 lower than the chlorinated paraffins. Then, next in the group, nonachlor, sum of PDBD6 and PDE7, including the decacongener, dieldrine, beta HCH, HCB have median ranges between 1 and 10, maximum up to 100. And then there are many chemicals below 5 nanogram per gram lipid, which is seen as background contamination. And this is seen as some concentrations also below the LOQ. The total sum of POPs ranges between 240 and 640 nanogram per gram lipid. Roughly 50% comes from pesticides, roughly 50% comes from industrial chemicals in more or less all human regions. In Africa, in Asia Pacific and Gulag, roughly 90% of the industrial pesticides comes from chlorinated paraffins, whether short or medium chain, and roughly 10% comes from other industrial chemicals, which is more or less PCBs. Whereas in Western and Eastern European countries, roughly 30 to 40% comes from chlorinated paraffins, and 60 to 70% comes from chlorinated from PCBs. If you look at the estimated global production, PCBs were historically produced roughly between 1935 and 1990 at about in a range of about 1.3 million tons over these 60 years. The chlorinated paraffins have been estimated to be produced annually in this range. It's difficult to estimate it exactly. Main producers are China and India. It was estimated that the total production until 2020 was about 30 million tons. And therefore, short and medium chain chlorinated paraffins dominated the share of POP groups of industrial chemicals. And this is certainly cause for follow-up. And as in the case of MCCP's regulatory efforts, although MCCPs have just recently been listed. Then important regional differentiation. Start with DDT as usually highest contaminant. The concentrations vary between UN regions and between countries in UN regions. You see it here. Africa has a range between 17 and 23,500 microgram per kilogram. So this is 3 orders of magnitude, and Asia Pacific is quite comparable, whereas, for example, in the Western European and others region, it's roughly a factor of 10 lower. And in the graph to the right, you see on the left side, the lowest level 17 found in Egypt, and on the right side, the highest level of 23,500 microgram per kilogram found in Ethiopia. And so in the round 2012 to 2015, and in the last round 2016-2019, these levels in Ethiopia were reduced to 77,000 roughly. Sorry. By the way, Tunisia is in the last round, yellow, 2016-2019, at the lower end of the frequency distribution, and the upper third of the frequency distribution would give more reason for follow-up. Next example, beta HCH. Again, a range between below limit of quantification and 1000 microgram per kilogram lipid, 3 orders of magnitude, most concentrations between or below 50 microgram per kilogram lipid. Some countries also above 200 microgram per kilogram lipid. Africa in the range up to roughly 50, and Tunisia is in the middle with, I think, below 10 or so. Tunisia and other organochlorine pesticides and industrial chemicals is the range of low background contamination below 5 microgram per kilogram lipid. Next example, PCBs. Again, you find a range over 3 orders of magnitude, roughly between 1 and 1000 nanogram per gram lipid, this time dominated by Eastern and Western European countries, and other regions have much lower concentration ranges. Again, you have to differentiate, you see, between regions and time. So this graph has 2 kinds of differentiations. You see the 5 periods performed between 2000 and 2019, and in different colors you see the different UN regional groups. Dark blue is Eastern European, light blue is Western European group, and you see the dominance, high values of PCBs in the 2000-2003 study for European countries decreasing over time. And you see here Tunisia participated in the last round and was roughly in the upper third at that time. Another example, dioxins. Total dioxins in the African group has the widest variation in concentration with total TEQ. Ethiopia, as well in the 2012 as in the 2019 study, at the lower end of the frequency distribution, and Egypt in the 2000-2003 study with quite high dioxin levels, comparable to levels as you would find in European countries at that time. Then, so you see in Egypt reducing levels until a follow-up study in 2019. Sorry. Then in the upper third, Cote d'Ivoire, Ivory Coast, and Congo, having quite high dioxin levels. Tunisia is more or less in the middle. Dioxins are always of concern, therefore we tried to help to identify also possible sources, and the dioxin pattern in Egypt could indicate combustion and drying processes. Then whereas in Ivory Coast on Congo, the pattern hints at consumption of clays, a practice called geophagy by pregnant women. For reasons of time, I do not wish to give more information here. Who wishes to follow up, there are some references left here. Then brominated contaminants, PBDEs, again, 3 orders of magnitude between 0.3 and 350 nanogram per gram lipid, with a median of 1.6, Tunisia below this median. HBCDD in Tunisia, all congeners below limit of quantification. The same is true for hexabromobiphenyl. Then to chlorinated paraffins. We differentiate here between 2 periods, 2009 to 2014, 2015 to 2019. And you see that Africa and the Asian Pacific group has higher CP levels on average as European or GRULAC countries. And in the African group, Tunisia is quite in the middle of the levels of chlorinated paraffins. Then finally, PFOS. Again, Tunisia is in the middle as well of all countries in Africa, as also if you compare it with the median ranges of all 68 samples from the 2008 to 2019 period. So both for PFOS and PFOA in the middle range. Finally, and important, time trends. Again, it is the aim to provide data for the effectiveness evaluation with minimization of sources of variation by the sampling design, harmonized protocol for representative pooled samples, and analysis of pooled samples by the reference laboratory. For clarification, the GMP guidance document says temporal trend studies should be able to detect a 50% decrease in the levels of POP within a 10 years period. However, there is no stipulation of a quantitative goal for a reduction or decrease in levels of POPs in countries or regions. The objectives are either to eliminate or reduce production, use and releases depending on the matrix, but the rate of decline is nowhere specified or required. If you start to assess time trends, you usually follow median or mean values. If you do this, then you see the problems. Overall, the DDT levels in all 5 regions and globally are lower in the 2016-2019 study than initially in the 2000-2003 study. However, you find a wild up and down depending on participating countries and so on. In this case, in Africa, participation of Ethiopia in the 2012-2015 study was very high DDT levels, which were reduced to the last round. So a much more precise approach is to estimate time trends based on results of countries with repeated participation over time. Then you see here for all African countries that there is a decrease to the following rounds. And also, you see reduction rates have to be seen in the context with the concentration range. Here for, anyways, for Ethiopia, you see high levels which are decreasing because there is a clear source use of DDT against malaria whereas at lower background levels, other factors like long-range air transport have to be considered, which is not so much in the hand of the countries. The GMP guidance document recommends to apply simple linear regression or TLCen estimator for power analysis of statistical trends. Important. Trends can be derived if the trend test is positive, p-values below 0.05. For this, you need a minimum of 5 data points. Many countries have less than 5 data points. So in these cases, you cannot derive a statistically significant trends, but then you get a tendency. However, you can combine points from different countries on UN regional base or global, and then you get statistically significant trends. With this, we calculated the overall decrease rate per 10 years. And you see for DDT, globally, the decrease is roughly 60%, for beta HCH 80%, for HCB 60%. Next example, PCBs. This example is for all 25 European countries, which had the highest levels at the end of the 80s, early 90s, and participated already in the first and second round of WHO coordinated exposure studies. You see that significant reductions were already achieved in the 1990s. The reason is that already in 1970, PCBs were first time determined in human milk, which then caused that already in 1973, OECD recommended to stop use of PCB in open systems. So you see a clear decrease starting in European countries already with the 1990s. The decrease rate roughly in the range of 90% between the end of 80s and 2090s in these countries with the highest levels. If you calculate it as a 10-year rate, then you see that roughly 70% is the global decrease rate for PCBs. Then for dioxin-like compounds, again, significant reductions were already achieved in the 1990s. In 1990, Germany, for example, held an international symposium and found that in Germany, the total daily intake would be exceeded. So therefore, measures were recommended to detect sources and to eliminate sources. And this concept was then later applied in 2001 by the EPU. So you see the overall decrease rate per 10 years for dioxins is roughly as well as for the total TEQ, 50%. PFOS between 2008 and 2019, again, in nearly all countries with repeated participation, decreasing tendencies from 2008 to 2016-19. And you can calculate it as well for all countries, then it's 48%, all countries with repeated participation, it's roughly the same. Decrease, increase of total chlorinated paraffins. We have seen the figure to the left already before, split into two periods, 2009-14, 2015-19. And you see that there is a slight increase in Africa. There is a significant increase in the Asian Pacific region. There is slight decrease in Latin America, a significant increase in Eastern Europe, although at lower levels than in the Asian Pacific region, and a decrease in Western European countries. Globally, an increase of 30% for chlorinated paraffins in human milk. So, to summary, you see we found median decrease rates for 10 years for a number of chemicals. However, an increase of total chlorinated paraffins as emergent POP in some UN regions and globally. So that would certainly ask for follow-up studies. Again, this is only a short overview. If you wish to follow up the whole picture, then much more information is available. And this comprehensive work was only possible thanks to the support of WHO, UNEP, countries, the national coordinators, funding bodies, laboratories over decades. So it's the success story of so many contributing to these studies. Now, some words on analysis, long-term quality control. WHO performed an interlaboratoriety study on levels of PCBs, dioxins, and furanes in human milk for qualification of laboratories to perform the third round exposure study. And it was only the CVU Freiburg which met all preset criteria and therefore was selected as the WHO reference laboratory for that round. In 2006, the EU had a call of interest for laboratories as EU reference laboratory, and FVO, Food Veterinary Office, and EFSA, European Food Safety Agency, assessed all applications, and CVR Freiburg was selected as the EU reference laboratory for dioxins and PCBs. This task was expanded in 2016 to all POPs and as the URL for pesticides in food of animal origin. All laboratories of the official food control have to be accredited since 1996. So you might understand that there are quite comprehensive quality control measures, which are all part in the book. PFAS was then done by Örebro University. Just shortly, we have internal quality control, procedural blanks, vegetable oil, spike, in-house reference material, and so on. And then the internal quality control is cross-checked in external participation and proficiency test. So for dioxins and PCBs, we participated in 32 PTs with 81 test samples and 40 pages describe it in detail. For organochlorine pesticide industrial contaminants, we have two methods for non-polar substances, for chlordecone and pentachlorophenol. Again, the same procedure, internal quality control charts from spiked samples, in-house reference material, and then external quality control participation in PTs. The pesticide lab participated in 53 PTs with determination of 150 analytes, which is 10 times more than listed as pesticides by the Stockholm Convention. Then PBDE, HBCDD, chlorinated paraffins, polychlorinated naphthalines require 4 different analytical methods. Again, you find the methods described, the internal quality control, the participation and proficiency test described in the paper. And University of Örebro published 3 papers, 2 on results and analytical methods, and 1 for validation and quality control. So then as last aspect, monitoring of POPs in foodstuffs. So first, as introduction, in the EU, we have 3 levels of laboratories, official laboratories performing the routine analysis, then national reference laboratories, and then on top EU reference laboratories, which then report to the European Commission. We have 44 URLs, from these 25 for food and feed, and again, dioxins, PCBs expanded in 2018 for POPs. We see Freiburg here as a URL in the middle of more or less Europe. The task of the URL for halogenated POPs comprises three groups: chlorinated POPs, dioxins, PCBs, chlorinated naphthalines, chlorinated alkanes, brominated POPs, PBDEs, HBCDDs, emerging POPs, fluorinated POPs, PFAS. The organochloride pesticide POPs are in the task of our UL for pesticides in food of animal origin. In the field of pesticides, the EU has established 4 reference laboratories for various purposes. And again, the correct title is for food of animal origin and commodities with high fat content, is also in Freiburg. The idea is that the ULs, of course, support the UL Commission and the NILs to organize interlab studies, to organize workshops, analytical methods, and have working groups for special tasks. So we organize proficiency tests and interlaboratory studies for the whole range of POPs in food and feed. And the participation of the national reference laboratories is obligatory. Official laboratories and other laboratories can participate as well. For this purpose, we have to be accredited as well, just for performance of the interlab studies and for assessing the results. The difference: PTs, proficiency tests, assess the analytical performance of laboratories. Interlaboratory studies assess a test method. This just gives you an idea of, I think these were 17 PTs performed over the 5 years and the whole range of analytes of interest covered. And if you want to follow up, there is the homepage where you can find more information, and the PTs are also open for other laboratories. It's free for NILs. Other laboratories might have to pay a fee. Finally, 4 chemical groups of interest and more recent developments: dioxins and PCBs, which is of importance if you want to follow up. Dioxin PCBs, you know the concept of TEF values. TEF values express dioxin-like properties compared to 2378 TCDD as most toxic congener, which then allow to determine toxic equivalence. TEF factors were introduced at the end of 80s. You see some organizations revising it again and again. At present, we have the TEF factors assessed in 2005 by WHO. These TEF factors, WHO TEF factors 2005, are at present the basis for maximum levels and action levels, as we have it in feed and food law in European legislation. And these have also been applied for the WHO UNEP coordinated exposure studies. And now new, there was more or less recently in 2022 a reassessment of the TEF factors by WHO. 3 congeners contributing significantly to total TEQs got reduced TEF factors for pentadioxine, for pentafurane, for PCB 126. So the conclusion is that the total TEQs will approximately decrease by a factor of 2 when the new proposed TEF factors will be applied. That's one aspect. The other aspect is tolerable intake. Tolerable intakes were recommended by WHO in 1998. A tolerable daily intake of 1 to 4 picogram TEQ per kilo body weight. And so in 2000, the European Commission Scientific Committee on Food proposed a tolerable weekly intake of 14, which is 2 per day, and concluded that given the average daily intake of dioxin, the dioxin-linked PCBs in European countries, a considerable proportion would exceed this TWI. At the same time, globally, the joint FAO-WHO Expert Committee on Food Additives, JECFA, concluded a provisional tolerable monthly intake of 70, which is also roughly 2 per day. However, just recently, 2018, the European Food Safety Agency concluded a tolerable weekly intake of 2, which is a factor of 7 lower than what was concluded in 2000. And it was confirmed again that the dietary exposure to dioxins and dioxin-like PCBs might be a health concern, and that a huge part of the population would exceed this recommended intake. So we have at present a mandate from the Commission to EFSA to convert the results in the new TEFs, to update the results data of the past 10 years, to update the risk assessment, and then we will see a comprehensive reassessment and revision in the EU legislation, and the UL for POPs is then asked to help to decide whether these new proposed maximum levels can be achieved with analytical methods. And for time trends, then there will be confusion, because then you have results for whatever reported with WHO TEFs of 2005 and then 2020 again, and you have a reduction of the factor of 2 only by these changes in TEF factors. Polychlorinated paraffins. First, for nomenclature, it is now recommended to use the term chlorinated paraffins for industrial products, to use the term polychlorinated alkanes as quantifiable main ingredient of chlorinated paraffins. So you should report individual chain lengths if possible, allowing an easier comparability, toxicological risk assessment, and to report the sum of measured PCAs. And it's a general recommendation that studies should be performed giving more data. The core working group Chlorinated Paraffins of the URL-NL network has developed a guidance document with quality control data, quality control criteria, and also proposing 2 kinds of analysis: semi-quantitative methods and quantitative methods. The idea is, we all know that analysis is quite different, but semi-quantitative method should be easier. Just do it, and if it is possible to find something, then think of quantitative methods. So for monitoring, the approach is to determine the sum of PCBs as semi-quantitative method with GCEI MS-MS, which is more or less affordable, against the threshold value, and if this threshold value is exceeded, then specific analysis should be performed. Brominated flame retardants. The Commission has asked for monitoring programs on brominated flame retardants in 2014. EFSA has assessed these results in period 21-24. The URL has developed again a guidance document on criteria and also proposed example methods for determination of PBDEs and HBCDDs in feed and food. And the reason is that the EFSA assessment of 2024 said it's likely that the current dietary exposure to PCDDs raises a health concern. So HBCDD, the EFSA assessment was the current dietary exposure to HBCDD does not raise health concern, exception breastfed infants with high human milk consumption. So then PFAS. The EFSA risk assessment of 2020 was done for 4 PFAS and for the sum of these. A tolerable weekly intake was established for the sum, and the content panel concluded that parts of the European population exceed this TWHI, which is of concern, with most important contributors, fish and seafood, followed by eggs, meat, food. For PFUA, also vegetables and drinking water. So the EU has established a maximum level for PFOS, PFOA, PFOS hexasulfonate, and PFNA, as well on individual basis as for the sum in certain foodstuffs of animal origin. No maximum levels for milk, there are only indicative measures, levels. In drinking water, the correct term for maximum level is minimum requirements for parametric values used to assess the quality of water intended for human consumption, which is only a longer word for the same meaning. For PFAS total, total means the totality of per and perfluoroalkyl substances. And for sum of PFAS, and this means the sum of the 20 PFAS listed to the right. So this is for drinking water. The UL has published a guidance document on analysis, again with criteria for feed and food, and has also an example method for determination of PFAS in food on feed. Analytes of interest to the right from various groups of PFAS. PFAS also have branched isomers, which is a little bit complicated, and so the UL performed also a PT on determination of linear branch and total PFAS. And in this guidance document, you have 4 different approaches available. Drinking water is separate. So the Commission notice of 2024 gives 2 methods of analysis, European norm methods with performance criteria and a recommended method. So drinking water is not in our hand of the UL POPs. We just informally exchange with competent analysts at the workshop. And however, we have to perform these analyses as official routine laboratory. Finally, the question is, with all these expansion of analytes as decided at the last COPs, these 7 newly listed POPs. So PF hexasulfonate is already covered. MCCPs would already be covered by the chlorinated paraffin projects. Long chain PFAS could be included more or less without problems into the PFAS method. Brominated dioxins, furanes, mixed halogenated are still under discussion. The UL-IO has 3 pesticides which can be included, and we have established already also method for UV filters, so that could be done. It would be one additional method to be applied from all these studies. With this, I'd like to thank my colleagues Alex Schechtele and Björn Hadebusch very much for all their help. You know, I have been retired, and so they updated me with more recent information. And I'd like to thank you very much for your attention. Thank you so much.